Okay, so in this video, we're going to put all of this together. So let's say we start with a pattern, or perhaps we started with a visual pattern that we then turned into a pattern. Both of those would be acceptable. In this case, we have a numerical pattern. So the first thing we're going to do is think about what are the missing pieces of this pattern. So when I look at -2, 1, 4, I notice that I'm going up by 3. So my next term would be 7, and my next term would be 10. So I can fill in the missing pieces. Then what I'm going to do is I'm going to fill in my table. So again, remember that X represents the term number. So that's the term number, and that's like, here's term 1, here's term 2, here's term 3, etc. So X is the term number. And then Y, they are the value of each of those terms. So term number 1 has a value of -2. Term number 2 has a value of 1. Term number 3 has a value of 4. Term number 5 has a value of 7. And term number 5 has a value of 10. So now we have to think about what our equation is going to be. And remember, we've now learned that an equation is y equals something x plus or minus something. The first one is what we go up or down by. It's our constant rate. So in this case, we notice that we go up by 3 every time we add a new number to our pattern. So that goes here. That is our constant rate. The second number, this is our initial value. That one can be a bit trickier to find, but remember the initial value is the value of y when x is 0. So it's like term number 0. And so one of the ways to do it is just to go backwards in your table. 5, 4, 3, 2, 1, and then just add a 0. Then go backwards with your pattern. 10, 7, 4, 1, -2. Go down 3, and you'll get -5. So that represents my initial value. So in this case, actually, I'm not going to have a plus. I'm going to have a -5. So my equation is going to be 3x minus 5. Now we're going to take that a step further, and we're going to graph that equation. We have our table of values. We have our ordered pairs. So we have the point 1, -2. So I can go to my graph, and I can plot the point 1, -2. And normally you would want your graph labeled like 1, 2, 3. It's just really hard right here. So I'll do the first few numbers, but it's really hard to do that accurately. It's a really small, so that was terrible on the left-hand side, but you get the idea. This is our x, and this is our y. So when we graph, remember, we go left, right first. We do our x coordinate first, and then we go up and down second. We do our y coordinate second. So if we go back here, I've forgotten it. Our first point we're going to do, well, we actually could do 0, -5 if we wanted to. Find 0, -5. 1, 2, 3, 4, 5, and that'll be right there. And then do 1, -2, 1, -2, it'll be there. And then the next one was 3, 4, over 3, up 4. And we can do one more. You really only need a few points. Once you have 3 points, it's really more than enough, but we'll do one more. 4, 7. So over 4, up. 1, 2, 3, 4, 5, 6, 7. And all of those dots represent points on our graph. I feel like I've missed one, and I have. I missed 2. 2, 1. So let's go back and just add that one. So now we have all 5. We have 5 points there. And we then draw our graph. So we actually get our line, we get our ruler out, and we connect our dots. And we want to make sure that we draw an arrow on both ends, because lines go on forever in both directions. Unless there's a context to it, unless there's like a word problem context, you can go all the way in the negative direction and all the way in the positive direction. So this is an example of taking our pattern, or we could have had a visual pattern, turning it into a table, finding an equation, and then actually representing that equation in a graph.